Hello students, in this video we are going to discuss 2.6 from motion in a straight line. A player throws a ball upwards with an initial speed of 29.4 meter per second. What is the direction of acceleration during the upward motion of the ball? So we need to write the direction of acceleration during the upward motion. Here for A we can write the acceleration is always vertically downwards. So when a body is thrown vertically upwards, the acceleration will be vertically downwards. So this is because of gravitational force. This is for A. For B, what are the velocity and acceleration of the ball at the highest point of its motion? So at the highest point, so the velocity will be 0. That is nothing but example for 0 vector. And acceleration value will be equal to acceleration due to gravity, that is nothing but equal to 9.8 meter per second square. Choose the x is equal to 0 meter and t is equal to 0 second to be the location and time of the ball at its highest point. Vertically downward direction to be positive, direction of x-axis, and give the signs of position, velocity and acceleration of the ball during its upward and downward motion. Here we can take the situation like this. This is downward direction, x is positive. Here suppose say x is equal to x0 initial position, and at highest point x is equal to 0 and t is equal to 0. T is equal to 0 second, x is equal to 0 meter as per C as given. Now we need to write the signs of position, velocity and acceleration of the ball during its upward and downward motion. So in this first case, in the C itself, during upward motion, assume that from here the ball is vertically thrown upwards. Then x value, that is position, is positive. That means x is more than 0. Here initially x is equal to x0, finally x is equal to 0. At anywhere x value is more than 0. That's why we are writing x is equal to positive. And velocity is negative, while coming to acceleration is positive. While coming to The second part in C itself, during downward motion. During downward motion, again x is positive and v is positive and a is also positive. Coming to part D, to what height does the ball rise and after how long does the ball return to their player's hand? Here two sub-questions are there again. We need to find out the height reached and how long does the ball returns to the player's hand. We can write here u is equal to minus 29.4 meter per second upward motion. U is equal to negative as per what has given the condition in C, and final velocity is 0. A is equal to plus 9.8 meter per second square, and how much time it will take and how much distance it will travel. So we can use v square minus u square is equal to 2a into displacement. Displacement can be written in terms of position x minus x naught, that is equal to 0 square minus 29.4 whole square is equal to 2 times of 9.8 into x value is nothing but 0 minus x naught. From this, x naught is equal to minus 29.4 into 29.4 divided by minus 2 into 9.8. This value is equal to 44.1 meter. And also we need to find out the time taken also. If we use v is equal to u plus at, from this 0 is equal to minus 29.4 plus 9.8 into t. From this, t is equal to 3 seconds. That means it will take to reach maximum height 3 seconds. But total time taken, that is also called as time of flight. Total time taken for the ball to return in the player's hands. So that is nothing but total time taken. That is also nothing but time of flight we can call. So that is equal to time of ascent plus time of descent. So how much time it will take to reach the maximum height? Same time it will reach to the player's hand. So 3 plus 3, that is nothing but 6 seconds. So this is the answer here for position, that is 44.1 meter height. So this is the solution for 2.6. Thank you. Please, if you feel it is very useful to you, please subscribe the channel